Hello, in this video we are going to be continuing our discussion on section 8.3. We will be graphing quadratics from standard form. So where we left off was discussing x-intercepts of parabolas. So to find x-intercepts, I'm going to go ahead and let y equal 0 and then solve. So I will replace my y with 0. I get 3x squared plus 6x. And then to solve, I do need to factor. So I will factor out my GCF, which is 3x, and then I am left with an x plus 2. Solving, I have 3x equals 0, or x plus 2 equals 0, meaning that x is either 0 or negative 2. So I input in y value of 0, and I got two different solutions. Those solutions were x values of 0 and negative 2. So my two x-intercepts are 0, 0, and negative 2, 0. To place these on my graph, I have an x-intercept here at the origin and one also at negative 2, 0. We know that parabolas are symmetric. So that tells us, since parabolas are symmetric, that our vertex must be somewhere exactly in the middle of those 2 points. So it must lie somewhere on that green line. So what I'm going to think about is taking the distance between these 2 points and then cutting it in half to figure out what this x value of my parabola is. So to find that, I've got a 0 and a negative 2. That distance is 2 units. So this entire distance is 2 units. If I cut that in half, I can find the distance on either side of my axis of symmetry, which tells me that this distance is actually only 1 unit. So that tells me that my parabola has a vertex somewhere with an x value of negative 1. So since parabolas are symmetric, that tells us that our vertex must lie on the axis of symmetry. Because everything is the same on the left and the right, our vertex must lie somewhere on that green line. So determine the vertex of the parabola using this conclusion. Well, we already talked about the fact that I must take the distance between the two x-intercepts and cut it in half. That gives me 1 unit. So that 1 unit puts me at an x value of negative 1. So then to figure out the vertex, I just go back and plug that in. Y equals 3 times negative 1 squared plus 6 times negative 1. So y is equal to 3 minus 6. Y is equal to a negative 3. So my vertex is the point, negative 1 for x and negative 3 for y. Go ahead and take a moment to pause the video and complete this page on your own. To find x-intercepts, I'm going to go ahead and let y equal 0. And then since we are dealing with the quadratic, I'm going to need to factor. So 0 equals, I can take out a negative 2 and an x, leaving me with positive x plus 2. So my two equations are negative 2x could equal 0, or x plus 2 could equal 0. So solving, I've got x is equal to 0, or x is equal to a negative 2. So when y was equal to 0, I got two solutions. My first one was x equals 0, and the second is x is negative 2. So x is 0, x is negative 2, and again, parabolas are symmetric, which means the vertex must lie somewhere on the axis of symmetry. So we just need to figure out where that is. I'm going to take the whole distance between my 2 points. So that whole distance here I can find by subtracting. So I will start with my 0 and I will subtract a negative 2. And I figure out that that distance between my 2 points is 2, which means that half of it must be on the left of my axis of symmetry and the other half will be on the right of my axis of symmetry. So if I take my 2 and divide by 2, I get 1, meaning that the distance on either side of my axis of symmetry is 1. So I'm going to go ahead and draw my axis of symmetry. And that axis of symmetry is 1 unit away from the intercept on the left, and it is also 1 unit away from the intercept on the right. So therefore that axis of symmetry is exactly in the middle. So x here is going to be a negative 1. To the left of 0 is negative 1. To the right of negative 2 is negative 1. So all the x values on that line are negative 1. So that means that my vertex must have an x value of negative 1. What I need to find is the y value. So I go back and I plug that into my equation. Negative 2 times negative 1 squared minus 4 times negative 1. That's negative 2 times positive 1 plus 4. Y is 2. So when I plugged in an x value of negative 1, I got a y value of positive 2. So my vertex is at negative 1, positive 2, which means my parabola actually faces downwards, and it will look something like this. So we've talked about a few different things so far. We've talked about A and B, we've talked about axis of symmetry, we've talked about how that axis of symmetry will help us find our vertex. One thing that we haven't talked about is the case where one of your x-intercepts is not on the origin. However, we still follow that same process of finding the difference between the two x-intercepts, and that tells us where our axis of symmetry will lie, somewhere right smack in the middle. Following through that process, we can derive a formula that will work for all cases of parabolas in standard form. Our x-coordinate of our vertex can be found by using the formula negative b over 2a. Negative b over a might be familiar from earlier in our lesson, but for our vertex specifically, we find the x value by plugging in negative b over 2a. Then, to find y, we must solve for y when x equals negative b over 2a. Or in other words, plug in x equals negative b over 2a. I'll show you one and then I'll ask you to practice a few on your own. So this equation is in standard form. If I write it with all the a, b, and c's showing, my coefficient on x squared is 1, so I've got 1x squared plus 2x, and then my constant term is a0, which means that a is 1, it means that b is 2, and it means that c is 0. So to find the x value of my vertex, negative b over 2 times a, I've got negative b, which is 2, over 2 times a, which is 1. So negative 2 over 2, which simplifies down to negative 1. So what I have found so far is that my vertex has an x value of negative 1. To find the y value, I plug that in. Y equals negative 1 squared plus 2 times negative 1. Y equals 1 minus 2, so y equals a negative 1. So now my vertex has an x value of negative 1 and a y value also of negative 1. So my vertex is the point negative 1, negative 1. Alright, go ahead and take a moment to pause the video and try these next three on your own. In my first example, I've got an a value of 2 and a b value of 4. So x is going to equal negative b over 2a, which is negative 4 over 2 times 2. Negative 4 over 4, which is 1. So my x value, negative 1. My x value is negative 1, and I need to find my y value. So I go back and I plug in that negative 1. I end up with 2 minus 4, so y is negative 2, meaning my vertex is at the point negative 1, negative 2. Here I've got a is a 1 and b is 4. C is 0, but we don't need c at this point, so I'm not going to write that in. The x value of my vertex is negative b over 2a, so negative 4 over 2 times 1. Negative 4 over 2, which divides the negative 2. So I know that the x value of my vertex is negative 2. So to find my y value, I just go back and plug that in. Y equals x squared, so negative 2 squared, plus 4x, or 4 times negative 2. 4 minus 8, y is going to be a negative 4. So my vertex is at the point negative 2, negative 4. Lastly, a is a negative 3, b is 18. So x is equal to negative b over 2 times a, so negative 18 over 2 times negative 3. Negative 18 over negative 6, which divides to positive 3. So I know that my vertex has an x value of positive 3. Now I only need y value, so I go back and plug it in. Y equals negative 3 times 3 squared plus 18 times 3 minus 24. So y equals negative 3 times 9 plus 54 minus 24. Negative 27, and I'm going to add these two to get plus 30. And y is a positive 3. So my vertex is at the point 3, 3. That brings us to the end of our video for today and the end of section 8.3. Thanks so much for watching and have a great rest of your day.